Good morning. Can you all hear me?
Yeah.
Thank you. Oops. Okay. Let's look at what we're doing. So I want to point out with test 4, it's a similar, oh, sorry, where are we at? No, we're not test 4 yet, are we? We're still in test 3. Test is due this Thursday, right? I lost track of time here a little bit. Yeah. All right. So yes, we're just doing, we're still doing a review. So the test is due Thursday. And today we're going to finish what we were doing with the review. So don't forget about the essay questions. Do you have any questions about that? Anybody have any questions about the essay questions? I've got a few in already, but not very many. Okay. So we were looking at, yes, the non-standard cells. I actually already have done an example of these. I'm going to go ahead and do another example. And what we're looking at is this one here, number 7. Now there's this X here is imaginary, and it's the anode. So the reduction potential equation for this, written as a reduction, is, sorry, my pen here is acting up a little bit. Let me had a little bit of water put on it. It's not good. Okay, let's try this again. Next 4 plus 4 electrons gives X. That is the reduction process. Now, what makes it a reduction is the fact that it's got 4 electrons and they're on the reactant side. So that's always going to be a reduction process. The other thing you'll notice is that the charge on X is going down from 4 plus to 0. That's another sign of reduction as well. So when you're coming up with the equations here, the anode ends up getting flipped because it's the anode. Remember, oxidation occurs at the anode, and this is a reduction. So the first step here is to change this into an oxidation. Now, you were also given a reduction potential in the question as well, 0.95 volts, which makes it now negative 0.95 volts. Now, the other equation we're looking at, you have to choose from one of these two, and you want the one with MnO4 minus and MnO2 and H plus, and that would be the top one, this one up here. That one doesn't get changed because it has to be a reduction anyway, and I just copy that as it is. Let me move it over just a tad. There we go. So MnO4 minus. And 1.70 volts. So the next thing I would have to do is figure out what needs to be multiplied in order to make those electrons equal. And I'd have to multiply the top one by 3 and the bottom one by 4. See if we have any questions so far? Now, if we do that, we'll end up with 3x gives 3x4 plus 12 electrons. And on the bottom, we'll have 4 MnO4 minus plus 16H plus 12 electrons. And that gives 4 MnO2 and 8H2O. Now the voltages don't change. You don't multiply the voltages. And was this one 1.70? Okay, so that'd be 0.75 volts at the end. Now the reason we do this is so we can calculate Q, and Q only includes everything that's got a concentration next to it. It doesn't include solids and it doesn't include water. So Q in this case is going to be, well, I missed something here, didn't I? dx4 plus, right? 3x4 plus up here. Okay. So that'll be x4 plus cubed. So we've got to do it to the power of the coefficient. And then down the bottom, it'll be MnO4 minus to the 4th and H plus to the power of 16. I don't think there's anything else there. And if you look at the number of things that we have that have concentrations, there are 3 and they match what's here. Then it's going to be a matter of plugging in those values. So we've got 0.84 cubed over 1.84 to the 4th times, let's see, what's it, 0.30 to the power of 16. So that's going to come up with a Q value, which we're going to end up plugging into the Nernst equation, which is given down at the bottom here. You can see it there, E cell equals E naught cell. That's this value up here. That's the voltage under standard conditions. Minus, let's see, 0.0592. It should be 0.0592 V over N, which is the number of electrons transferred in the balanced equation, which is 12. It's whatever it had to be to make it equal. And then that's times log of whatever we got up here, the Q. Let me see if I can find my calculator here. Calculator. All right, doesn't matter. I've got my calculator here, so I'll use the hand one. All right, let's have a look. Okay, I get pretty big number. I get one, let's see, was it 12 million? Yeah. So, let's see, let's see if I can convert that into exponential notation. Can anybody do that math for me as well? Just make sure I'm getting the right answer. But I'm getting uh, 1.2 times 10 to the, I think it's this, I think it's to the 7th. Can somebody do the math for me, please? Make sure I'm getting the right answer there. Is anybody doing it?
I'm working on it.
Okay, thank you. Looks correct. Thanks, Cathode. Okay. Okay. And so what I get there is going to be the E naught cell value, which is 0.75 volts, minus 0.0349. Now, if we look at significant figures there, it should come out to be 0.72 volts. And that will be the final answer. Does anybody have any questions?
I have 2 questions.
Okay.
So is the top voltage always going to be negative? Because I know that in these problems that we're switching it, but is that the case that it's always going to be negative? Because my question was going to be, how do we know for it to be 1.70 voltage minus 0.95? If it wasn't negative, would we add it?
You would, yeah. That's the thing. If the reduction potential you were given, in this case it's positive 0.95 volts, that could be negative, Katie, and if it was, you'd have to switch it to being positive.
Okay.
And then you would add them together, yeah.
Okay, and then in these problems, as well as on the redox reactions, I'm having trouble with the charges. And obviously you get the charge, or the charges, or the electrons in this case, since it's number of electrons.
Now this one is a little bit easier because the equations are actually balanced for you already. So you don't have to do any balancing of equations. The electrons are what they are, but you do have to make sure that the electrons are the same in each, and you need to multiply each reaction by the appropriate number to make those reactions equal with the electrons. But there is no other balancing involved, Katie.
Okay, because this one, they give it to you.
Yes, yes.
Yeah.
I mean, the equation is already balanced.
Yeah, okay, yeah.
All right. So it's really just saying to yourself, well, what do I have to do to get the right number of electrons? And, you know, spoiler alert here, it's always going to be the opposite. You know, if you look at the electrons in each, Could we multiply them by the opposite on each one?
Yeah.
Do you see what I'm saying?
Yeah. And then what's the most efficient way to put that Q equation into your calculator?
Well, what I did was I did 0.84 and I used a caret mark. What do you have on, which calculator do you have?
Yeah, I have that.
Okay. Yeah, so I did 0.84 caret 3, right?
Mm-hmm.
Then I did divided by, and then I put down started parentheses, and I did 1.84 caret 4 close parentheses. And then I did divided by open parentheses 0.3 caret 16 close parentheses. And the reason I put divide there is because it's on the bottom, and I just multiply everything across the top and divide everything that's on the bottom.
So you do the divided by before the MnO4 value, you're saying?
No, I did 0.84 cubed divided by 1.84 to the fourth, and then divided by 0.3 to the 16. So anything that's on the bottom has a division in front of it.
Okay. Okay. Yeah. So you're doing it separately, you're saying?
Sort of, but I mean, it's all in one equation, right?
Okay.
I mean, it's all in one line. I'm not splitting it up at all.
For some reason, when I was doing the practice quizzes, I kept getting these answers like 0.2 off.
I don't know why that would be.
Yeah.
Could be that you were rounding as well while you were doing it, and that's not going to be helpful, I can tell you that.
Okay.
All right, any other questions? I mean, that one looks bad. It's actually not that bad, really. Okay. A lot of moving parts to it, I suppose, but it's not really that bad. Okay. Okay, so for this one, this is one that involves some dimensional analysis, a little bit of practice. So 2.60, and you are given the Faraday constant value up here, but you have to realize that it's going to be amps is coulombs per second. Times 3.16 hours. And then it's going to be, that'll give you coulombs. Then you use the relationship with the moles of electrons. So it's 1 mole of electrons. And that's going to be 96485 coulombs. And then there's a relationship between moles of electrons and X solid. And it's 1 mole of X solid. Divided by 6 moles of electrons. Now I get that from the equation that we're given here. 6 moles of electrons produces 1 mole of X solid. You are also given the molecular weight, 46.60 grams of X per 1 mole of X. And that gives you your answer. And the answer is going to be, let's see, grams. So something grams. Does anybody have any questions? I won't do the math on that. It's fairly simplistic, but does anybody have any questions? If I was to do the math though in my calculator, I'd do 2.6 times 3.16 times 3600 divided by 96485 divided by 6 multiplied by 46.6. And that would give me my answer. Does anybody have any questions for number 8? Okay. All right, let's look at the redox balancing here. So what we have to do is balance this equation. So the first thing you want to do is split it up into half reactions, which is going to be XO3 2 minus, minus 2 minus, it doesn't really matter, gives X2 1 plus, and then you've got QH60 I kind of like to put them under each other with the arrows. QH60 gives QH2O2. So it's a multi-step process, and you can follow all the different steps here. The first step is to balance Q and X. Now X here I can balance by putting 2 in front of the X. O3 2 minus. Does anybody have any questions so far? The Q is already balanced. The next thing I need to do is balance the oxygens. I do that by adding water, and I need to add enough oxygens in order to make it balanced. Now on the top one, there's 2 times 3, which is 6. So I need to add 6 waters to the other side. And on the bottom, we've got H2O to make that one work. Does anybody have any questions?
So why did you add the H2O on the bottom?
Because you've got 1 oxygen on here and 2 on the other side. And to make that work, we need to add 1 water.
Okay, yeah.
Is that all right?
Yeah.
Okay. Does anybody have any questions so far? On the top one, we've got, for the hydrogens, we need to add H pluses. There's 12 H pluses, 12 H's on this side, which means I need to add 12 H pluses over here. That's 6 times 2 is 12. Now this is a little bit more tricky with the hydrogens. We've got 8 on this side and 2, which means I have to add 6 H plus over here. Okay, so I'll stop there for a second. Does anybody have any questions about the number of hydrogens, H pluses? Okay. Now on the top one, we need to find the number of electrons. And what I had told you when we went through this in class was to figure out the charge on each side, and then the difference would be the number of electrons. And you add that to the side that has the higher charge. So on this one, the total charge is 8. And on the bottom one here, the total charge is 1. Does anybody have any questions? The difference there would be 7. Any questions? Now, if you look at that, it's -7 plus 12 is 5, minus 4 is 1, which matches the 1 on the side. That's where the 7 comes into play. Now, on the other one, it's 0 and 6, so it'll just be 6 electrons over here. So that's 0, and this is 6. All right, does anybody have any questions?
I have a question that's not related to this exact one. I understand this one.
Hmm.
But, like on the practice quizzes, there was some on there that had, what do you do if like, say you have a 1, like a 1 and a -1.
Okay. So let's say it was 8 and -2. Okay. Yes.
Okay.
So that would be 10.
Because you're doing minus -2.
It's minus -2. That's exactly right. I mean, if you look at if you did a number line on it,
So if it's 1 minus -1, then it would be 2. So if you have a positive
yes,
and
that's right. That's right. Yeah.
Because it's evening out the charge, so you have to make up for the fact that the other one's
Right, but you see, if you do the number line,
yeah.
right, you'll get 10, right?
Okay. And then the other question I was going to ask is, there was also some on the practice quiz that they like say the bottom equation or whatever you might call it, it's had like, for example, Fe, I can even give you one. Okay, how about this? One was PB4 plus, and then one was PB.
Mm-hmm.
So would I not do anything on that? Because it doesn't, the charges, we're not evening out the charges. You would just leave that?
Well, the PB4 plus 4 electrons gives PB. Is that what you're saying?
But I'm saying, as far as even just like the equation itself, to even it out, like, you know, obviously we're adding the H2Os, and then we have to go make up for it to make sure we have enough H pluses on the other side. If they gave you PB4 plus arrow PB, then that's even, right?
Well, it's even for hydrogens and oxygens, yes, but not for electrons.
Of course, yeah.
Right. So you don't have to do those steps for that.
Okay.
There was another one like this one.
There was one with iron like that.
Look, this one's an interesting one, Katie, too. So if you have C2O4 2 minus goes to 2CO2. You'll notice that the carbons balance and the oxygens also balance. So then we're just adding electrons.
Okay.
See, that'd be -2 and 0. The difference would be 2, and the 2 electrons go on this higher side, which is the 0 side. So that one's kind of interesting too. So sometimes the oxygens balance out already. Maybe even sometimes the hydrogens do too. So you don't have to do anything, but you have to realize they balance.
Okay.
Is that okay?
Yeah.
Okay. Let me close that down here. All right. Let's see. So we've got 7. We got 6 on the bottom. So I'll have to multiply the top one by 6 and the bottom one by 7. I'll do the water and the H plus first. Those are the hardest ones. So the water, we've got 36 on the top, and on the bottom we've got 7. So 36 minus 7 is 29. So 29 waters. Oops. It goes on the other side. All right, does anybody have any questions about where I'm getting the 29 from? Okay. The next one, the H pluses, 6 12s is 72, 42. So it should be 30H plus on this side. Any questions? So everything else needs to be brought down. We've got 8 XO3 2 minus. And we've got 7QH60. And on the other side, we've got, let's see, 6x2 plus. It's not really making sense.
I
Oh,
have a question.
sorry.
How do you get 30 for H plus? Because I thought it's 6 times 12.
Hang on, let's have a look. 6 times 12 is 72. And on the other side, we've got 42, right? 7 times 6.
Okay, I did it separately.
Well, you can't because it's on both sides.
But can't you do one side at the top and make two separate again and then cancel it out?
You could. But I've already done that already. 72 minus 42.
Okay.
So I did that once. I did make a mistake here though, because I was looking at this 8 here, unfortunately. But 6 times 2 is 12. But I kind of caught that because I saw it was 6x2 and I knew that the x's had to balance. So I knew there had to be 12 on this side anyway. So I knew I'd made a mistake with that. And then plus 7QH2O2. Now the thing with these is you always know if you're right or not because you can always check the balancing. So the x's are 12 and 12, that's fine. The oxygens, we've got 24 and 7 is 31. And on the other side, we've got 29 and 14 is 43. So something's amiss here. Let's try this again. 12 times 3 is 36 and 7 is 43. So again, I didn't do the math correctly on that. 12 times 3 is 36. 7 plus 7 is 43 and then 43 oxygens on this side. So that's right. The Q's are okay. The hydrogens, we've got 42 plus 30 is 72. And then over here, we've got 29 times 2, which is 58, plus 14 is 72. So the hydrogens also balance out as well. The charges, we've got, let's see, that's XO3 2 minus, right? So that's 12 times -2, which is -24. Plus 30, which is 6. And on the other side, we've got, I guess that's x2 1 plus, isn't it? Six times 1 plus, which is 6. So it is balancing. And then add that all together. It'd be 12 plus 7 is 17, plus 30 is 47, plus 29. 76 plus 6, 82 plus 7 is 89. So that would be the answer. You just put it in there. And you can't get the right answer unless you balance it correctly. You could guess it, but boy, that would be a pretty good guess. Does anybody have any questions? Really, the only way through these is just to practice them. If it was me, I just practice this question, just one question on the practice test again and again until I was getting the right answer on a pretty continuous basis. It's all practice. It really is. What you'll find though when you first start out, you'll always be sort of making these little mistakes. I mean, I made some mistakes going through this myself. I was able to correct them because I saw the mistakes as they happened. Sometimes you can do that, sometimes you can't. Sometimes it's a matter of just erasing it and starting again. Especially if you're not getting the right answer. But the thing is, you always know if you got the right answer because it will always balance.
Well, yeah, but if you do the charges wrong, then you don't, because it's gonna, if you did the charges wrong and then you multiply them correctly, they're all gonna match up, but it's still.
Oh, no, they won't. No, I mean, the charges won't match up. So you can, and at the end, the charges won't match. I mean, you'll know it's not balanced, Katie. That's the thing. That was you, Katie, right? You said that?
Yeah, but if you're multiplying the other equation by the opposite number and like the numbers match and everything like that, then they will match if you just write that wrong.
No, they won't balance. That's the thing. You'll end up getting something that won't completely balance. All right. Does anybody have any questions?
Professor,
Mm.
I got 91.
Oh, you got 91. You might have. I didn't. I don't know if I don't know if I did the math correctly, and I was trying to do it in my head.
Oh, okay.
12 and 7 is 19. Yeah, I can see that. Yeah, I think it is 91. You're right. Because I think it's 12 and 7 is 19. I think that's where I screwed up my math there. But if I did it in my calculator, I think I would have got it right. But yeah, just keep practicing them, and and make sure you're getting the right answers. And I would just continually do them. Just do question 9 again and again. I don't think that the questions on this test are that hard, really. There's a lot to some of them, but they're not that bad. Not if you sort of trudge through them, you'll be fine. All right. Any other questions about number 9? Okay. So number 10, that's the direction of flow problem we talked about. And the first thing you should do is look at the equations that you're given. And then write them out. And what I would do is I'd write Q plus an electron. You have to write them as reductions, which means the electrons have to be on the reactant side. So Q plus an electron. And you know that it's minus 0.900 volts. And the other one is R plus an electron. And that gives R, and that's going to be 0.200 volts. And you always flip the smaller of the two. And the smaller of the two here is going to be the minus 0.9, numerically smaller, whatever is the smallest value. So the one you flip is going to be the first one. So that becomes Q is Q plus an electron. And that's going to be positive 0.900 volts. And the bottom one is R plus an electron. Gives R. That's going to be 0.200 volts. And you can see that when we add those together, we'll get 1.100 volts. So when we're looking at the reactions themselves, we can classify them. The first one is an oxidation, because the electrons are on the product side, they're being given away. The situation is that it's dissolving. The Q is turning into Q plus. And the other thing we know is that it's the anode, because that's where oxidation occurs. So for the other one, it's a reduction because the electrons are on the reactant side. It's plating. The R plus is turning into R. And it's the cathode. So those would be the things I would write down for each of these. Does anybody have any questions so far? So we're looking at the diagram here. The first one is direction of electron flow. That's what it's asking for first, direction of electron flow. And the electrons, as you can see, are going to flow from the Q side over to the R side. The Q is giving up the electrons and the R is giving them. Now, according to the diagram, I equals Q, J equals Q plus, K equals R plus, and L equals R. So it's Q on this side and R on the other side. So looking at the flow of electrons going from the Q side, which is over here, to the R side, we know that the answer there is going to be B. So electron flow is B. Does anybody have any questions? Direction of flow of R plus. Well, R plus is plating and R is on this side. So the answer is G. So the arrow represents what's going on with the R plus. It's going towards the electrode so it can plate. Remember we said that over here. Does anybody have any questions? The species being reduced. Well, whatever's being reduced or oxidized is always going to be on the reactant side here. It can only be Q or R plus as being the answer. And what it's looking for is the one being reduced. The one that's being reduced is this is the reduction, R plus going to R. And then that means that the species being reduced is R plus, which is going to be K. Does anybody have any questions? Direction of flow of Q plus. Now Q plus is on this side and it's dissolving, as you can see here, Q is dissolving. So it's going to be F is going to be the answer. So that's Q plus flow is F. Does anybody have any questions? Okay. Let's see, the cathode. The cathode is the electrode at which reduction is occurring. Now, the electrode is always a solid, so that would be R in this case. Not R plus, but R. And that would be, the cathode is R, which is going to be L, according to this here. All right, does anybody have any questions? Okay, species being oxidized. The species being oxidized is going to be the Q. Q is turning into Q plus. So Q is I. All right, does anybody have any questions? Okay. The oxidizing agent and the reducing agent. Now, the oxidizing agent is the species being reduced, and the reducing agent is the species being oxidized. Species being oxidized and the oxidizing agent can't be the same thing. The agent means it's what's causing the oxidation, and that's always the one being reduced. So the oxidizing agent is K, and the reducing agent is going to be I. So they switch around. Does anybody have any questions? Okay.
Did you just scroll back up to that little diagram?
Which, this one here? Mm-hmm.
Yeah.
Do you have a question?
Yeah, I mean, I understand like what you're saying. I just am having a hard time like,
My tip, Katie, would be to do the reduced and oxidized first, right? And the reduced
Yeah.
one will always be the oxidizing agent, and the oxidized one will always be the reducing agent.
yeah, I guess I'm just confused because I would think that the reduced and the oxidized would be like when I look at this and when I consider the lab that we did, I would think that it would be L and I versus I and K because K is, because
Okay.
where
I
it's
think you
coming-
might be getting mixed up with anode and cathode. See, the thing is, R plus is the species that is actually being reduced, not the R. R plus is turning into R. That's what's being reduced. The Q is turning into Q plus, so it's being oxidized. Are you clear on this?
Yeah, I guess I just am having a hard time relating it to the diagram and all the different.
Well, it's not so much about relating it to the diagram, Patty, it's relating it to these reactions. Because the Q is the Q is involved in the oxidation, the R plus is involved in the reduction. So I think that's what you've got to focus on. It's not so much the diagram, the equation here. And R plus, as you can see, is K. It's not L. That's R. That's R plus. You know that because down here, see, K is RNO3, which is R plus, and even says it there. Is that okay? Is there anything else I could say about that that could be helpful?
No, so I guess, I mean, what would be like a helpful hint maybe to write those different things that you determine, like to
Yeah.
kind of draw
Yeah.
that graph and kind of write all those things in.
Yeah, that's just my point. That's what I want you to do. I want you to do exactly what I'm doing here. You know, exactly what I did here. You should do that so that you can keep your information together. I wouldn't do it in my head.
Yeah.
Any other questions? So nitrate flow is going to go through the salt bridge. It can either be C or D. And a good tip I can give you here is nitrate flow is always the opposite to electron flow. So electron flow is B, which means nitrate flow will be C. The other way of thinking about it is that the Q needs nitrates because it's forming Q plus, and the R plus is turning to R, which means it doesn't need nitrates anymore. So so it's going to be Q is going to travel. So the nitrates are going to travel from the R side to the Q side. Does anybody have any questions? And the last one there is the anode, and the anode is where the oxidation is occurring. So that's going to be Q, and that's going to be I. That's the answer. All right, does anybody have any questions? Okay. All right. So that's that's the entire test there. So there's not a whole lot to it, really. It's not. I don't think it's quite as bad as test 2, for example. But you know, you will have to do some work on it, especially practicing those redox equations. And you know, the more you practice them, the better you'll get. That's just the reality of it. All right. Does anybody have any questions? Does anybody have any questions? Okay. Does anybody have any other questions about the test?
Do you mind going over number 6 really quick?
6, 6, 6. 5 and then 6. Okay. Okay. So number 6, you're using the equation delta G equals delta H minus T delta S, which is given somewhere in the test, I think just above. And the mission here is to figure out the sign on each of them. Delta H, in this case, because it's endothermic, means it's positive. The delta S we have to get by looking at what's going on in the reaction and looking at how many particles we're getting on each side. So we're getting CrPO4. I'll write it out here. Now, it's important that we write down the states here as well, because those are going to be important. So the solids we just ignore, and the 3 NaCl, what I would do is I treat that as 3 boxes containing Na plus and Cl minus, which is a total of 6. The Na3PO4 is 1 box containing 3 Na pluses and a PO4 3 minus. And that's going to be 4 species, and the other one is 1 Cr with 3 Cls. That's going to be 4 species as well. So the total is going to be 6 on this side and 8 on this side. Now the delta S is going to be the sum of the entropy of the products minus the entropy of the reactants, which effectively means 8 minus 6, which is equal to positive 2. So delta S is therefore positive. So all of that has allowed us to determine that we have a positive delta H and a positive delta S. So after that, we can go ahead and do a little math here. We can say, well, it's going to be positive. So delta G equals positive minus T times positive. Now what we can see there is there's going to be some variation with temperature. If T is low, then delta G will be positive and the reaction will be non-spontaneous. And the other one, T high, the delta G is going to be negative and the reaction will be spontaneous. Does anybody have any questions? So who asked me about that? I didn't quite catch who it was.
It was me, Anna.
Okay. So what's going on?
I get everything just like up to the point where like you just figure out the answer, I guess. I don't know.
Okay, so the answer here is just really it's just pure math. So if you got positive and you're subtracting a value that's positive, if that value is small, the answer will be a positive value, smaller than what you had, but still positive. So if you pretended, for example, T was 0, you could see that delta G would be positive, right?
Right.
But if you said T was very high, you can see that that second part in the parentheses would be a big value, and you'd be taking a positive value and subtracting a larger value to get something negative.
Okay. I think I'm getting it.
Now just one tip I can give you here. If delta H and delta S are the same sign, either both positive or both negative, you'll always get this variation in temperature. They'll switch, but you'll always get this variation in temperature. If they're opposite signs, then there's no variation with temperature. Delta G will always be positive or always be negative if they're opposite signs. And that can be helpful too. Sorry, go on.
So you're saying if delta H and delta S are both positive
or both negative,
or both negative, then the answer will always be spontaneous?
No.
No. Okay.
Oh, sorry, say it again, please. No, repeat what you said. I'm sorry.
If delta H and delta S are both positive or they're both negative, the temperature will always be spontaneous?
No.
No.
What I was trying to say was there'll be variation with temperature, meaning you'll get a different result of high and low temperatures, just like we did here, because they are both the same side here.
Okay.
So the temperature will affect whether it's spontaneous or not. What I was saying is that if the signs were opposite, positive and negative, right? The signs were opposite. Then then you could do that. You know, you could say that it's always going to be spontaneous or always going to be non-spontaneous. All right, does anybody have any questions? Anna, do you think you're okay with that now?
Yes, I think so. Thank you.
Okay. And Katie?
Yeah, no, I don't understand it, but I guess I can just go watch some of the videos about it.
Is there anything I can help you with here? Have you watched the videos for these?
I watched your original lecture for it, and
Yeah.
I believe I watched it, but it might have been a while ago.
Yeah, I would watch that again because the original lecture is pretty good. It explains it pretty well. Then but you have to understand each part of it as you go through. But if you understand each part, you'll understand the whole thing. Just break it up into little bits. You'll see it's not that bad. Okay, does anybody else have any questions?
So what's the final answer on that one then, on that specific question?
Well, let's see. The reaction is non-spontaneous at low temperature and spontaneous at high temperature. That's reflective of what I've got here, Katie. Do you see that? Delta G actually isn't part of the answer.
Yeah, I see it.
Okay.
So if they were both negatives,
Mhm.
would it just be the opposite, that the reaction
Yes.
is spontaneous?
That's
Okay.
right. It would be non-spontaneous at high temperature and spontaneous
Right.
at low temperature. So
Okay.
it would be the reverse.
Okay. Thank you.
Okay, good. That's good. All right, any other questions about this one? Yeah, I think we might have made some headway here with some people on this one. That's good. It's what this is one of those questions that once you understand it, once you get it, you'll never get it wrong, because it's just something that, I don't know, it's just one of those, you understand it, you know, you can understand it, and it's you always get it right every single time. I can't say that about the redox, because it's so easy to make a mistake on the way through, and you have to continually do it until you're getting till you get it balanced. All right, does anybody have any other questions? Okay, any questions about anything else on the test? Anything else about any of the other test questions?
It's not about the test, but do you mind just going over that quiz that we have to do?
Quiz, or do you mean the essay questions?
No, it's the quiz.
Oh, the quiz. Okay, you're talking about the units quiz?
I think so.
Okay, sure. Let's take a quiz at it. Okay, so you're talking about this one here.
Yes.
Let's have a look. So it's really an exercise in dimensional analysis. So the way you'd handle something like this one, you have to find the units for delta H, which are going to be kilojoules per mole. So that's going to be number one. And then the 298.2, the unit there, or I should say 0.2 there, that should be temperature, which is K. And that's going to be number 2. Delta S is joules per mole per Kelvin, so that's number 3. And that needs to be converted, because that's kilojoules over here. This needs to be converted from joules into kilojoules. So it's going to be, on 4 is going to be 1,000 joules. No, sorry, it's going to be 1 kilojoule. And 5 is going to be 1,000 joules. And delta G is also going to be kilojoules per mole, but that's not part of it. The other things weren't used were the 1 joule and the 1,000 kilojoules, so those get 6 as the answer. Does anybody have any questions? Yeah, so that's all you're doing. You're just putting in the units, just matching them up.
And you can just do this as many times.
Yeah, it's not proctored either.
Okay, thank you.
Right. But you can do it as many times as you want. I don't think it gives you the correct answers, but you know, you can do it till you get 10 out of 10. It's unlimited. But do you have any questions about it?
No, I was just curious as to
Okay.
what to do for that part.
Okay. See, the thing is, I can't have you do dimensional analysis as part of the actual test that you're taking. So this is kind of my way of making sure you understand that there are units here and that they do need to cancel.
Okay, thank you.
Okay. Any questions? All right. Does anybody have any questions? Any other questions about anything for the test here? so that's due. The test is due on Thursday. I'd recommend you do it earlier than that. But you know, don't leave it all to the last day. I mean, for this one, I don't think it's that bad. If you can put in some serious study time, I'd say probably say 6 hours. I think should be enough to prepare you for the test. If you've already been studying, then you're good. You're good to go. If you haven't started studying, start studying today. And I think you should be okay. This one is not that bad. I couldn't say that about test 2. Test 2 required a lot more work, I think. I think test 3 is kind of a gift in some respects. Not that everybody would agree with that statement. Does anybody have any questions? All right. Well, I guess I'll leave it there. If anybody has any questions, I'll hang around and see if anybody needs any help. For some of you, I'll see you at 9:30. Others of you, I guess I'll see you next week. But if you need any help, let me know. All right. I'll see you all later.
Thank you.
Thanks.
Professor,
Yes.
I actually have one question about the essay questions. I can't